live. Thank you so much for joining us today. While we wait, it would be super fun if you could introduce yourself in the chat. Just give your name, any info you want, specifically where you're from. We've got folks from all over the world right now. I am joining you from beautiful Boulder, Colorado in the US, and I'd love to hear where you are from. And if you've just joined us, thank you so much. We're just going to hang out for another couple of minutes while we wait for everyone to come in. We'll get started in about 4 or 5 minutes past the hour. In the meantime, please introduce yourself in the chat. Let everybody know where you're from and maybe what you're working on or what excites you about IPFS. We've got folks from all over the world in this meeting right now, which is pretty fabulous. So welcome, and we'll get started in just a minute. Worldwide representation of IPFS only gets better and better. I'm looking at the chat. It is so cool to see folks from all over the planet here right now on this Friday and or Saturday, depending on where you are, I guess. We are going to get started in about a minute. So if you haven't dropped your name or where you're from in the chat, we'd love to hear from you. right, everybody. It is 5 minutes past the hour, so let's go ahead and get started. Thank you so much to everybody for joining us today for our IPFS meetup, our first edition of 2021. Y'all, we made it through 2020. That alone is an achievement. And there's all sorts of cool stuff to share with you today. Quick introduction, next slide, if you do not mind. That is me. My name is Jessica Schilling. My pronouns are she and her. I am part of the IPFS Web Browsers and GUI Working Group. Pleased to join you today from sunny Boulder, Colorado. Next slide, please. We have a few bits of administrative and courtesy reminders that we want to go over before we get started. We are totally thrilled that you are here, which is absolutely wonderful. Thank you for taking time out of your busy day, especially on a Friday/Saturday. A couple of things that we want to go over before we start. It is very important to remember that this event does abide by the IPFS Community Code of Conduct, as does everything else that happens at IPFS. We take this super seriously because we enjoy being good humans and enjoy being kind to the humans around us. There is a link to the Code of Conduct from our wonderful Jen Turner in the chat if you want to click through that. If you have any questions at any point, just drop them in the, we're using the chat box today. We don't have a separate Q&A box today, so just drop them in the chat and somebody will get back to you. We'll answer questions in sort of an asynchronous manner after presentations if you have questions about an individual presenter's topic. Also, you can check out all kinds of other good things on our IPFS YouTube page, including past events like this one, past meetups, as well as many of our working group working sessions and tutorials, lectures, all sorts of other good stuff. So it's super, super cool. That link is also in the chat. And if you watch today's meetup and it inspires you and you want to give a talk, whether it's a detailed talk or a lightning talk, something short and sweet, we would love to have you. It's super easy to get that ball rolling. Just email ipfs-community@protocol.ai and someone will get right back in touch with you to chat about scheduling and all that. So we have a super great agenda for you today. Next slide, please. I will show you. So first up, we've got a 2021 planning update from the IPFS core team, specifically the wonderful David Choi and Kadir Topal, here to talk about some of the good things that are going to be going on in 2021 and how our planning is rolling along. After that, we have a talk from Dr. Ian Preston about Peergos, the private web. Following on from that, Victor from Humanode is going to be talking with us about human beings as a trust layer on top of IPFS. And we'll be wrapping up the main portion of our meetup today with Matt Wisniewski talking about decentralized peer-to-peer communications. He's coming at us talking about Vault 74. So without any further ado, I will hand things over to David and Kadir to talk about IPFS planning.
Thank you, Jess. All right. Hey, hi, I'm Kadir Topal from Duisburg in Germany, and I'm the IPFS Growth and Product Development Lead. And if you can go to the next slide, in November 2020 now, we asked the IPFS community, and that includes people at Protocol Labs, we asked them to propose themes for us to focus on in 2021. We wanted to hear from the community, and the community really delivered. It's been pretty incredible to see the breadth and depth of the proposals and the passion of those who advocated for them and argued for those proposals. So many thanks to everyone who has contributed. The feedback has really blown us away. So now we wanted to give a quick update on the whole process. So David and I will talk a little bit about what happened, what's currently in progress, and what to look forward to. So this will be a bit of a short update, and then we'll hopefully give you a bigger one on the next meetup. Next slide, please. All right. So as I just said, the first part of this was really reaching out to the community and being really broad in what we asked, what we consider as our focus for 2021. So that part is done now, and we've already moved on to analyzing that content, that feedback, to first identify a couple of questions that we need to answer, regardless of the focus area. So things that cut across a bunch of different proposals. So we've identified those questions and have worked on trying to get answers to those questions. Another thing that we've done is we've looked at initiatives that we might prioritize regardless of the focus area. And I'll come back to those later, but there are things that we would do regardless of which item we pick or which themes we pick to work on. So there are of course things that are ongoing, but there are also things that we know we want to improve. So we've started prioritizing those initiatives as well. And then as a part of this, I know the IPFS version 1 was already one of the themes and one of the proposals, but of course, it includes, IPFS version 1 can include a lot of the proposed items. And so what we have started working on, and this is one of those key questions, is what would an IPFS version 1 look like? What would be a part of it, and what would it entail, aside from just from code changes? So those are some of the things that we have already started looking into, and I'll let David talk a little bit about what we are currently working on.
Awesome, thank you, Kadir. I'm David. Nice to meet you all who haven't met yet. And I'm located in Phoenix, Arizona. So it is pretty pleasant weather. Next slide, please. Yeah, so just to talk through what's going on right now. I know we're already almost a month into 2021, and we're looking to nail down what the project's plan for the year is, and help share that with you all and get feedback on what that is. So right now we're exploring some use cases where, you know, there's so many cool things that were suggested by the community, so many directions we could head to help narrow that down. Having a few use cases in mind to actually work towards getting fit between some sort of market and what IPFS brings to the table. What is a great way to narrow things down. It moves the ball in other ways where across many different use cases, you can see improvements, and trying to figure out what that set looks like to focus our efforts in 2021 is a goal right now. As a part of this, once we have some use cases in mind, especially taking the working set of requirements for IPFS v1 and refining what those are, kind of narrowing the scope as much as possible, because there's so many different ways it can go. And then getting feedback from everyone in the community, sharing that with you all, and coming to a consensus on what that looks like. Another key part of this. And then from there, we can really sift through and determine the priority areas to tackle in 2021. And a key part of this is figuring out how to do so. So again, there's so many cool ideas that were proposed by the community, and it's kind of like efficiency is of the essence. Upfront in 2021, we want to work on the things that kind of unlocks the ability for everyone in the community to focus on the areas and help contribute in ways that are most helpful for the way they're using IPFS. And you know, how do we do that, and how do we unblock and unlock the full potential of the community? That's also very much top of mind for us. So like Kadir mentioned, a lot of exciting stuff going on, and you know, stay tuned. We should have very tangible stuff for you all soon. Kadir, throwing it back to you.
Thank you, David. Let's go to the next slide. So yeah, let's talk a little bit about what to expect. What can you expect from here? So as David said, we've already started looking into narrowing the focus a little bit. And one thing that we have seen is that the proposals have uncovered opportunities for so many different audiences. And of course, one thing we already know is that we're not going to focus on just one single audience in 2021. We'll hopefully be able to offer something that actually addresses many different audiences across different use cases. And one part of that, one way to actually achieve that, that we are seriously looking into at this point is making IPFS more modular, so that you can contribute to parts more easily, but also use parts of IPFS more easily that are more relevant to you. So the idea is that we structure IPFS in a way that makes it easier to push the things forward that people at Protocol Labs, people in the community really care about, where it makes sense for them. And IPFS as a library is one thing that we are seriously looking into to make that possible. Because yeah, from all the proposals, it's clear there are so many different audiences, and Protocol Labs on its own isn't going to be able to address every single one of them. We have to somewhat prioritize, but this is one way we can actually open up the opportunity for people who really care about certain things to move forward on them, to push them forward, for us not to be the bottleneck to those things. So that's something that you can look forward to. Another thing, I mentioned this at the beginning, is there are things we know we want to make better. And that's regardless of the focus area that we choose. There are things around the observability, around performance, around docs, and the whole developer experience that we know are currently not as good as they could be, and that are areas where we definitely could do better. And those are things that we do want to improve on, regardless of the 2021 focus area. So we've started prioritizing some of those. A lot of those came out of the proposal process. And so that's something that you can expect to happen regardless of what we focus on. And then, as David said, we're currently right in the middle of some of those things, which means that there will be an update, and hopefully soon, but expect the next update in the next IPFS meetup, where we'll hopefully be able to talk more confidently about the path that we would like to prioritize across the proposals that have come in and the feedback that we have and the conversation that we've had in the meantime. And then hopefully we'll be able to present something that's a little bit more long-term. But yeah, hopefully that's going to be our next update. I think you're muted.
All right. Thank you so much to Kadir and David. If you have any questions about anything in this or any other presentation, just drop them in the chat. We will answer those asynchronously. And as Kadir said, look for more information as our planning process continues in the coming weeks. And big, big thanks to everybody who has been part of this process, who has submitted their ideas and their proposals. It means more than you might even know. So thank you so much for that. Moving on, I want to introduce Dr. Ian Preston of Peergos to talk to us about the private web. Ian, are you good to go?
I believe so. Can you hear me?
Yeah, wonderful.
Excellent. Sorry, right, screen share as well. Yep. How's that?
Looks great.
Awesome. So I'd like to start by sharing our vision for the private web. But what do I mean by the private web? Imagine a web where you don't have to log in separately to every different site and where you own your identity. Imagine a web that's not constantly surveilling your every action and using it against you. Imagine owning the data that you create in apps and being able to use the data securely in other apps. This is the vision of the private web that we're trying to build with Peergos. Currently, it's easy for anyone to share media, websites, or apps privately or publicly in Peergos, in any browser without any extensions. Peergos is a protocol for private storage, social media, and applications built on top of IPFS. This includes user-controlled identity, sandboxed applications where no surveillance is possible, untrusted servers, and quantum resistance. Most of us are ex-physicists, so we care a lot about that. And protected metadata, which we'll be talking more about later. But let's start with a quick overview of the architecture. The physical architecture is quite flat. Every Peergos instance has an embedded IPFS instance, and these all communicate over BitSwap, the DHT, and peer-to-peer streams. There's also a PKI, which stores its data in those IPFS instances. But the critical thing that we rely on a lot is that this doesn't depend in any way on DNS or the TLS certificate authorities. Of course, if you want to access a Peergos server over DNS, you can if you want, but the protocol doesn't rely on it. The logical architecture is also quite simple. Each user has a home server, which is responsible for storing their data. They can have as many mirrors as they like, and each home server can store as many users as it can handle. So within their home server, each user has a set of key pairs, which are used to sign the Merkle roots of data that's in IPFS. And these are called, we call these mutable pointers. They're similar to IPNS, but with slightly different properties. And the only other thing we have is a mailbox. So this is it's a blinded encrypted mailbox for reasons which we'll discuss later, and that's the one thing that's not stored in IPFS, which is to do with the quantum resistance. Peergos breaks down into several trust boundaries. So these are mutually untrusting regions. So if any data or hashes cross one of these boundaries, then it's verified by the recipient, whether it's a hash or a signature. So for example, the Peergos client doesn't trust the Peergos server. The server itself doesn't trust IPFS. And apps are also sandboxed off from the client. So these sandboxes, these are actually operating system level processes. And you need to do that if you care about things like side channels from things like Meltdown and Spectre. This arrow on the left is an interesting one. So this is the case of an S3, direct S3 block store, which we'll talk about later. But in that case, the block store itself actually verifies hashes of writes from the client. But we'll see more about those details later. During file upload, a file is split into 5 megabyte chunks. Each of these are independently encrypted and then split into fragments, which are then stored in IPFS. And the critical benefit we get from this, well, one of the critical benefits we get from this chunking is it allows us to hide the size of files. So the different chunks of a file can't be linked together from the server's perspective. So you end up with a maximum of 5 meg size for a chunk. And actually we go even further. So we pad the files before encryption to a multiple of 4K. So then you end up, the only possible sizes of a chunk in the entire system, there's 5 meg divided by 4K, which is 1280. So we try to keep the entropy very, very low. We do access control, and it's serverless access control. So it's capability based. Every file or directory has several symmetric keys associated with it. And if you want to grant someone access to an entire subtree or just one file, you can do that by just sharing the key with them. And then they can decrypt the file, or if it's just a metadata key, they can decrypt the path and the metadata, including the name. There's also a write crypt tree, which is a bit simpler, but still also based on symmetric keys. And the one property both these crypt trees have, which we care a lot about, is to do with quantum resistance. So for the privacy of your files, we only rely on symmetric encryption and hashing. And neither of these are broken by a quantum computer. They're a little, you get a 2x speed up, but nothing significant. Whereas asymmetric encryption is totally broken. So that's why we don't rely on that anywhere in the crypt tree structure. The other thing we care a lot about is metadata. So there's a long list of things the server can't see: file names, paths, sizes, and properties, things like the MIME type, modification time, even whether something is a file or a folder. And because of that, the server also can't see the directory topology. It can't see the number of files or the number of directories or the sum of those. But the other kind of metadata we care about is the social side of things. So who has access to a file can't be seen by the server, nor even how many people have access to a file. And along similar lines, the social graph. So that's where the mailbox I mentioned earlier is blinded. So the server can't see who's sending a follow request to whom. And so your social graph is totally under your control. The main thing the server can see is an upper bound on the total amount of space used. And if you care about that, you can just fill it with empty data. So that's the architecture. Now for some highlights from 2020. At the beginning of 2020, we already had photo galleries, video and music streaming for arbitrarily large video, a text editor, and a PDF viewer. In 2020, we added to-do boards or Kanbans, so you can plan whatever it is you're trying to plan privately, and fast encrypted file search. So that sounds trivial, but in an end-to-end encrypted system, it's actually pretty hard to efficiently do file search. But we were pleasantly surprised with how fast it turned out to be. Now, the following three things we haven't actually announced yet, so I'm giving you the inside scoop, but you can already try them out on our beta server right now. The first of these is a calendar. So it's a private calendar. The model is every event is stored as a standard iCal file in your Peergos space. And this means we can leverage the sharing capabilities of Peergos. So you can share individual events with your friends, or indeed generate a secret link to an event to share with anyone. The second cool thing from 2020 was peer-to-peer web hosting. So this lets you basically host a website, it's a static website, directly from a folder in your Peergos space. You get instantaneous updates, and there's no cryptocurrency required for publishing or updating. And it's basically a single click to publish. Once you've done so, you can view your website via any public Peergos gateway. So we've set one up at peergos.me, and it would be your username.peergos.me. But a much cooler way to view it is a peer-to-peer way. So if you run Peergos locally, then you can view it at username.peergos.localhost. And if you're viewing it that way, then it's totally independent of DNS. And you've got the secure, authenticated peer-to-peer delivery of Peergos and IPFS. But wait, there's more. The next thing was a social feed. So we've been building up to this one for a while. So it's a feed of things that have been shared with you by people that you follow in Peergos. And obviously it's end-to-end encrypted, so it's 100% client-side assembled. This means that there's no AI and no ads. As well as all these applications, we've made some big server-side improvements as well in 2020. So the first one of these was the thing I mentioned earlier, the direct S3 block store. So in normal operation, a Peergos client gets all its data from the Peergos server that it's talking to. But with a direct S3 block store, the client still authorizes reads and writes with the Peergos server, but it then talks directly to S3 for both reads and writes. Now reads, you can see how that might work, but writes sounds a bit tricky, especially when there's multiple users around. But the way it works is the block store's content addressed. That's the way IPFS uses it. And what we do is that when the Peergos server authorizes a URL, it includes the hash of the thing, the file that's being written, and S3 verifies that. So S3 will reject an invalid write where you try to change the data maliciously. And obviously the cool thing about this is it reduces the bandwidth requirements of the Peergos server by about 100x. So a very small server can suddenly host a lot more users or a lot more data. The next cool thing, server side, was fully concurrent garbage collection. So you reach a point, especially with with a remote block store like S3, where garbage collections can take up to a day. And during this time, other pin operations can't proceed. So there are a few features of our design that allowed us to get around this. The first one is a transaction API, which helps us prevent the blocks from being GC'd before they've been pinned. And actually, we realize we don't even need to pin them at all anymore, because all our pins are implicit from the mutable pointers that I mentioned. And so during writes, everything's happening client side. So the server doesn't really know, doesn't have any concept of a file or anything. So you just start a transaction and then you annotate every block put with that transaction. And that allows us to not collect those blocks if there happens to be a GC before you commit. And this is fully concurrent, so there are no global locks. And yeah, writes can proceed concurrently. But that's not all. There was plenty more in 2020. So we managed to increase the bandwidth of uploads and downloads by about 4x, mainly by increasing the maximum block size. We've sped up navigating around your file system by about 10x by an improvement to Cryptree. And we made saving text files 7 times faster. But by far and away, the biggest highlight for us in 2020 was being awarded a Horizon 2020 Next Generation Internet Architects grant to extend our decentralized social media capabilities. So this is what we're going to spend most of the next year working on. So within those plans, we're going to extend the social feed to allow more general posting and commenting. We're going to implement decentralized group messaging, specifically not using the MLS protocol, as well as an email bridge. So there's plenty of fun stuff coming. So thank you very much. If you want to hear more, then go check out our website or sign up to a beta, or you can ask questions in the chat. Thank you very much.
Wow, Ian, thanks. This is the point at which I'm supposed to say thank you and say something to summarize what you just said. But like, I don't even know where to start. Peergos has clearly been busy in the last year, and that's a lot of really impressive, really cool user-facing features. And thank you for the inside scoop on what you've got coming up in your beta. If folks want to learn more about Peergos's vision for the private web, please visit peergos.org or at Peergos on Twitter. I'm kind of overwhelmed, so thank you. Next, I want to introduce everybody to Victor of Humanode, who has a really interesting presentation on human beings as a trust layer on top of IPFS. Victor, are you good to go?
Yes, I'm good to go. Thank you, Jessica.
Excellent. Feel free to share your screen.
Yep. Hey, everyone. My name is Victor. I'm a core member of the Humanode team. We're building a distributed financial system where one human equals one node. Or as we say in IPFS community, one human equals one replica. Why? Well, every public permissionless, now they're blockchain networks, they are based their security on capital. They base security either on staked tokens or on equipment of miners. And well, this approach is susceptible to external attacks. Like when you have a network with higher capitalization than this one, it can easily attack it, either directly buying out assets, or it will create a secondary market outside the target network and basically manipulate the price of the asset, eventually buying out the target network asset and attacking this permissionless network. And what we're doing in Humanode, our security is based on collective verification of human existence and all people who became humanodes. I have to say, frankly, we had that idea like almost for 3 years, but we had no idea how to implement that. And it became possible only in 2020, thanks to advances in biometrics, especially liveness detection. thanks to advanced matching of fully homomorphic encrypted biometric data, thanks to the private computations in permissionless manner by guys from Enigma. And of course, well, huge kudos to the Protocol Labs team for inventing and implementing the Merkle CRDT cluster. Well, basically, when we have a network where one human equals one node that is capable of financial transfers, that means that the fees that the network, that the protocol collects, will be divided equally among every human node. As there is no block reward, because again, we're using the IPFS invention, which is Merkle CRDT, any monetary system can be built upon without these block rewards. And moreover, it opens doors and the way to the one human, one vote decentralized organizations. And as you have seen, the state tokens DAO are just terrible at the moment. Well, thanks to the blockless nature of Merkle CRDT, we've got pretty cool features there compared to blockchain. First, less redundant metadata, and second, flexible transaction persistence time. That means that if you're sending like $10 to your friend and you don't really want to pay the costs of this for this transaction, for this data to be kept forever, what we can do with Merkle CRDT, we can unpin the data from IPFS, not hold it anymore. And basically the costs become lower and lower. Of course, if you want to keep the transactions till the heat death of the universe, you're always welcome. Now, how do we implement IPFS here? And where do we use it? Basically everywhere. And let's start from the creation of Humanode, okay? What we do, we ask people to scan their biometric modalities. Yes, first we're using external biometric modalities, face recognition, fingerprint, and iris recognition are among the most advanced, for example. But later, if we find out that that's not enough for security, we're also going to introduce internal biometrics. That means neurosignature with brain-computer interfaces or DNA. But let's go to the slide which explains how can you create a human node and how the system works. We have three actors here. It's client device, public IPFS cluster, and private smart contract. So this public IPFS cluster, it actually gets, well, it's public. You will ask how we can put biometrics, such as sensitive data there. Well, we first encrypt it with fully homomorphic encryption right on the client device, and only then we send it to the IPFS cluster. Basically, when a potential human node submits its encrypted feature vector from the biometric modalities, the public IPFS cluster performs one-to-many computations over that data to find out whether this person was a human node before or he's really a new one. Well, basically, after that, we get the score. We get the score that tells us, has he been there before or not? And the score is then sent through the client device to private smart contract. The score is again encrypted. We have to decrypt it right there in the private smart contract. And the private smart contract understands what the score means. And then he authorizes the public key of the client to have a validator key or not to have it. So now we have permission for a new human node to finally join the network. Let's look at how the network looks like. Yeah, here we came up with a nice figure for Merkle CRDT, but I'll jump straight to the tech. We reuse existing tools from the IPFS project to implement networking and data replication level here. We use Merkle CRDT for the state replication. And it becomes possible now to implement a key value store, which looks like Merkle trees in AAVL from Cosmos. So thanks to the Protocol Labs team, we can leverage a data store component that provides a unified interface to access data. We're picking a distributed Go data store implementation using Merkle CRDT. Well, it is basically based on the BadgerDB as permanent storage. It uses libp2p, pub/sub, and the provided pub/sub broadcaster as a broadcaster component. A user-defined DAX syncer component to publish and retrieve Merkle DAX to the network. And for the interface, the node initializes an IPFS Lite client. So thank very much, IPFS team and Protocol Labs. You were a great inspiration for us. Basically, when all the external components are properly mounted, the data store is ready to be used by a node instance. Since it's a key value store, we use prefixes to define separate data buckets. And well, here for the application logic, which represents transaction processing and validation logic, we defined two sets of buckets. The first set includes epochs, which we use instead of blocks in classic blockchains. And each epoch has a number as a key that points to a list of transactions. And on application level again, transactions, which is a bucket holding a set of confirmed transactions. And consensus participants here decide whether to include or not to include transaction into that set. If the transaction is confirmed, its CID, content identifier, and validator signatures are added to the set. And the body will be replaced through DAX syncer. Well, basically, the second bucket represents accounts and validators. Well, this is where we combine the knowledge that we have from the public blockchains, Cosmos mainly, and IPFS. And this is how we'll build the Humanode network. Thank you.
Thank you very much, Victor. There's a lot to take in there. That is absolutely fascinating and some really versatile and multifaceted uses of the IPFS stack. Some really interesting takes on governance. Also appreciate your Sylvester Stallone cameo that you got in there. So thank you for that. If you have any questions, please drop them in the chat for Victor. Also, you can keep tabs on what Humanode is up to next on Twitter at human_node. We will keep things rolling along as much as I have all sorts of questions too. But we will keep things moving along because we have one more presentation today that is sure to be fascinating, featuring Matt Wisniewski. Vault 74, decentralized peer-to-peer communications. Matt, are you good to go?
Yep. Thank you.
All
Thank
right.
you.
Feel free to share your screen.
Sure. Okay. Can you guys see it okay? Looks
good.
Cool. So I don't have any beautiful slides to show you guys, unfortunately. All the slides look great, by the way, guys. That was awesome. So I'm going to go over a little bit of a tech demo and hopefully show you guys why you should care about your privacy and get people that might be new to the decentralized web a little bit excited about it, excited about IPFS, and hopefully excited about what we're working on. So Vault 74 is a decentralized chat built on top of IPFS. It uses Textile as a middle layer to interface with IPFS. And the goal of Vault 74 is to build a application where you can screen share, you can video chat, file share, and host meetings, do everything you want to do with a normal application. and hopefully abstract all the crypto stuff behind the scenes. So, people who aren't enthusiasts can jump in and use it and, learn about why blockchain's awesome afterwards. So we've got servers to communicate with large groups. You could send firm requests, which right now are smart contract powered. Everything in the application is built to be configurable, so you can swap out classes as long as you use the same interface. We have here right now for Textile, our database protocol. You can switch that out with whatever you want. The idea is to build the app as a springboard and then hopefully have the community drive what the best solutions are for the application. We have built in here, let's see, embeds, so you could send links. You can send, your favorite music playlists or your addresses to get paid, whatever you want to do. It supports all the stuff you would expect in an application. Again, that's the goal, is to have everything kind of like you would see in Slack, Discord, or anything else, and just kind of, take away the tech side of things. And, as exciting as the decentralized web is, it needs to not be a pain point for people to adopt it. So that's kind of our methodology up front. We also support payments. Again, this is that might mess up my screen share a little bit, but again, this is something that can be swapped out for different crypto payments and hopefully fiat in the future, but that's not our focus right now. Again, the use of IPFS is implemented for file sharing. So you can upload files, let's see, straight through the inline uploader. And then, you get the links to the files and everything like that. You can also send them straight to your friends. Oh, sorry, having issues with the lovely M1 Mac. Let me get this refresh real quick. You can share files inline with your friends and stuff like that as well. So if I go through and let's see, I can either copy paste the files or I can upload them directly through the upload tool. Right now, we're just uploading them straight through the IPFS library. We plan to also use textile buckets in the future. That way they're automatically pinned and we have better management of those files per user. And yeah, I won't demo calling and stuff like that. I mean, it works, but it's kind of awkward to demo on a call. You can configure everything. Shield your eyes, business people, they like light themes. So we have light themes. We have a bunch of different themes based largely around the different themes in my editor that I just kind of took the colors from. But, you can make it look like whatever you want it to look like. We're actually, if you are excited about it, you can earn some badges, kind of superficial, but cool for the future to show how you contribute to the project. Again, everything's configurable. You can choose your own bit rate. Everything's going through a peer-to-peer network, which you have signatures before the peer connection is established to ensure you're talking to who you think you're talking to. And then you can stream it as high a bit rate as WebRTC allows, provided your connection can handle it. The application is 100%, 99% serverless. We have a peer-to-peer signaling server right now, but I have ideas to put that on IPFS as well. So the end goal is to have the application be completely serverless. You can load it on a USB drive. You can throw it wherever you want, and you don't have to worry about anyone in the middle snooping on your data or your privacy. It's got a bunch of other stuff like keybinds. We plan to support authentication via hardware wallets. Right now it's going through MetaMask. That's soon to be abstracted as a secondary option and use local accounts as a default option. All our contracts are public. The entire code base is public. So if you guys do want to look at what we got going on, you can go on the GitHub and check out all the code. You really shouldn't trust anything you can't see the code. Yeah, that's the bulk of it. We are looking at some more solutions. Everything is right now mostly going through Textile. We are looking at different chains like Matic and stuff like that as options for different protocols in the settings. But let's see, what else could I demo? Yeah, I think that's pretty much the bulk of what we have going on with the application. There's a lot of planning ahead for content creators. I come from a background in content creation, so we're sort of targeting that space first, as well as the gaming space. This is a community I know well. So a lot of the streamers, content creators are facing DCMA issues, issues with copyright holders flagging their content, whether for justified or unjustified reasons. So servers will also have integrations to a lot of social platforms. So let's say this event went live on IPFS's server, it would automatically have a now live channel pop up where people can chat and interface with the presentation, show your support with crypto donations or whatever you might want to do with that. In addition, with our Spotify integrations, if you do want to host music that maybe you don't own the copyright to, Spotify has a great listen along feature, so we can sync that up with the videos. As far as the files, we're also looking into redoing this editor to have folders and more of a Dropbox-like solution. We also are looking into having desktop sync, so any files you upload to folders on Vault, you can add that as a synced folder, and then share that folder with your friends to also have them sync files. So good for business and, even just friends sharing, maybe Thanksgiving videos where they all did something crazy or whatever. You can have those files synced between users automatically. And let's see, so the tech stack right now, most of the identities are Ethereum smart contracts. Looking into other options for that. We're not sure if we're going to switch that out. It really depends on the near future with Ethereum and how quick it's going to be. With that, all the firm requests and stuff are also sent through those smart contracts. Right now, you just send an Ethereum address and it looks up on a registry to see if that user exists. We're also going to have the traditional username, pound, some number identifier in a registry to look up addresses in a cleaner way. Super excited about IPFS to see where it goes, and hopefully this brings a attainable, interface to the decentralized web to a lot of people. I think privacy is super important, and I think people are finally starting to care, especially with the recent WhatsApp stuff and just our current world. And hopefully, we hope to make that easy for people and do it in a way that is directly useful to them day to day. That's basically it. I guess I can, if there's any questions or whatever, I could take those or, yeah.
Ladies and gents and everyone in between, let's hear it from Matt Wisniewski with Vault 74. Also want to single-handedly thank you for wrecking the productivity of everybody else for the rest of the day as we all go to download this and play with it.
I appreciate it.
You got any questions? Drop them in the chat. I was trying to sneakily put in like a GIF in our slide deck of the like head exploding emoji, but I was too busy watching all of this happen. We will leave the stream open for just a couple of minutes longer. If anybody has any questions or any discussion, just sort of leave this as a bit of an open channel for a few minutes. But we will see you next month. If you want to get more information on this meetup, which does happen every month, or really anything else in the IPFS universe, follow us on Twitter, find us on YouTube. We also have a fantastic weekly newsletter that you can subscribe to. All of those links are in the chat. If you're listening after the fact and can't see the chat, probably the best place to start is ipfs.io or at IPFS on Twitter. We'll send you down the rabbit hole of everything else that you need. I want to give a big thank you to everybody. Thank you for joining us. Thank you for taking the time to attend. And we hope you have a wonderful rest of your day and rest of your weekend.